Hello, everybody, and welcome to EPICS, an easy platform for identification of complex spikes. This is a very interactive tool which allows you to label your complex spike data, train the convolutional neural network, detect all complex spikes, and then finally visualize the results during post-processing, all on a single platform without requiring you to have any fancy computer with a GPU and also without requiring you to write a single line of code. So let's get started and see all its features and how it works. Okay, so let's start with the first step, which is labeling your data. And before we start doing that as well, let me just point you quickly towards these icons here on the top left part of each section that you see at different places. These are basically some info icons. If you just place your mouse over these icons without clicking, you should be able to see a window popping up which shows you some relevant information that might be important for you while you're using EPICS. You can also place here and you can see again some other information that is important to guide you basically on steps that you are in some with some information that you would need. Okay, so as I said, let's get started with labeling the data. For that, you will first need to input your data. And here, for that, you can just set some parameters. So what are the parameters in your data? So in this case, a pop-up window opens up and you see that there's a sampling rate in Hertz. So our sampling data was 25 kilohertz in our lab. You can adjust this based on the sampling rate of your data sets. Then what you see here is the high frequency action potential signal. So this is the variable in our case is named as high, then the LFP variable name LFP, and if you have already your complex spike labels, you can also add them and name that variable as whatever, and but just make sure that this is the, the name with which your variable is stored in your mat files should also be the same here in this case. Basically, these are the variable names which the program will use to plot results and everything else. Okay, so in short, your sampling rate, your high frequency action potential variable name, the LFP variable name. If you are doing this for the first time and you do not have any complex spike labels, you can leave this empty. But in our case, we do have the labels, so I just keep it as it was before and press OK. Now, after you have adjusted these settings, you can now add your Purkinje cells for manual labeling. So let's click here and go to where my data is stored. So in this case, my data is stored. Let's see where it is. Um, yeah, it's there you go. Okay, so we have this in this folder here. Okay, so these are just a couple of Purkinje cell recordings that I done a couple of years back, and these files are MAT files, like I've said before. It's better if the program only accepts MAT files in this case. And you can now either select one cell, press open, or you can select all the cells and press open as well. And this will load all the files at the same time. So let's load all the files instead of one, because that's what I guess would be the easier. You don't want to label, you don't want to basically upload one file at a time if you have many. So let's just think that you have many cells and you're uploading all of them at the same time. So let's press open. By doing this, what will happen? Yeah, you can see that it's loading the files. And there you go. So what you see here on the left are basically the files that you have just uploaded. So let's just go with the first one on top and press plot. This will basically plot my action potential signal that you had adjusted the name of the variable that you had basically adjusted here in the set parameters button, and the LFP signal, which is in parallel recorded at the same sampling rate, by the way, uh, on the bottom here. Now, as I said, we had some complex spike data that we had labeled earlier, which is what you see here are these labels. Okay, so let's go and see how we can label the data now. So obviously this looks like a mess here, which is because the whole entire long recordings have been compressed in this window. And what you want to do is perhaps zoom in a little and view your complex spikes. So for that, you can see that there are these buttons on top. So if you press R on your keyboard, or can just click this button here, you will see that you will start zooming in. I prefer using the keyboard shortcuts, so I will switch back to that. If you want to view the whole trace again, you can click on this Q or press this button here. It'll again reset the whole thing back to the full. You can select 1 second window and see how many complex spikes are there inside this or whatever signal you're looking for. In this case, you can see that there are these shaded red regions. These are basically your complex spike labels. You can zoom in further by pressing this 50 milliseconds button, and it shows you very clearly what we have here inside. These are all simple spikes, by the way. Okay, so let's go back to the full version here again, to compress them all back together. Now let's try the keyboard shortcuts. So what I would like to use, I would like to zoom in here in this part. So I can just press R, and you can see that I'm going in. And now what you can do is you can basically, if you go here, you will see that you can also go forward and backward. So you can press D to go back. So this will basically, or you can use this bar to scroll back also, by the way. Like I said, I prefer using my keyboard shortcuts. You can also use something else. So here you go, I'm there. I press on R, go D, 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 press, and again R, go back, and D. And you can keep zooming in until you see the complex spike very clearly. So this is already the labeled data. I can, if I'm not happy with this complex spike label for some reason, or I'm doing it for the first time. So what you can just do is just click on this red shaded region again, and you have simply deselected the complex spikes. Now, if you want to select a complex spike, so assuming that this is your first try, you would just press wherever you think the complex spike starts. I try to use this as my, this little peak down one here that you see. I try to use this as my, wait, I think I made a mistake. So I will just go here, and I would just use something like that and define this as my complex spike. So as you have done this, you have already selected the complex spike. What I forgot to mention earlier was that the moment you upload these files, for example, let's load a new Purkinje cell and plot. What you will see is that it also shows you how many complex spikes have been selected already in that cell. So your complex spike labels had 45 complex spikes labeled, which is what is seen here. And now if you zoom in again with the button R, so let's go here and go back with D. You want to go forward, press F, and you can keep going forward and backward. And let's just go in the very beginning of our data set. So scroll back to the first sample. Then I press R, zoom in, go forward until my first complex spike appears. This is going to take some time. There you go. Cool. So what you see is that this is a selected complex spike. And if I want to now again press this, and what you see is now that this complex spike was deselected, and that's why the number is 4. So it's consistently updating the complex spike labels that you are selecting. So you would do basically just again, you would click this and select this complex spike. I think this is where it is. You can go back and zoom out. What you can do is, in this case, you can go to the next complex spike, the next labeled complex spike. Again, this only works if you have a labeled complex spike. If you have not labeled, then you may have to scroll back and forth to find the complex spike. So this looks like a good complex spike. Well, I leave it like that. I probably go to the next one, also looks good, and the next, and next, and next. You can deselect this again, like I said before, and reselect if you are not satisfied with the label in this case. So it always allows you to go back and forth between cells in different parts of your Purkinje cell recording, and then select and reselect until you're fully satisfied with your labels. This is very important. I suggest that you take your time and label these complex spikes, because the more cleaner your labels and the cleaner your signals are, the better your algorithm will be, your results will be, and obviously the better the algorithm will perform. So assuming that you have done this, now some tips that I would like to give you uh, is that we recommend that you select a couple of complex spikes from the beginning of your recording session, some from the middle, and some from the end, so that you capture all changes that can probably happen during a long recording session in the shape of your complex spike. So your detection will be much more robust. All right, cool. So basically, you will do this for every cell. You will plot, you will select your complex spikes labels using your action potential and LFP signals that will update these things. You can use these buttons on top to navigate, and then you can go to the next cell, plot again, label your complex spike, and do this for all cells in your data set. And you can see that there are, in this case, labels available. Once you're done labeling your complex spikes, by the way, you don't need to have so many labels as you see here. These are just some test data sets, so it's okay. But in general, you will just need around 10 or 15 labels at max from one Purkinje cell. Let's say 5 from the beginning, 5 from the middle, and 5 from the end. And that should be really sufficient to form a training set. So once you have done this, you can either store these labels individually by pressing the Save CS Labels button. So if you are doing each cell and you want to save these labels for later on, like what I did, you can save complex spike labels, and this will save individual file, like I said. Select the location wherever you want to select, or you can select all the labels that you have just generated right now by manual labeling, and you can store all these labels as one file that will basically be the training set or the training data for your algorithm. So let's just go and do that. So this is basically the training data. It's by default named as that. You can change the names as you wish. Select the location wherever you want to save these training data. So I'll go back to my data, and I can save these training data, let's say, in a new folder, and I call it training data. Save it here, and you're done. So by doing this, you have already saved your training data. This is basically how easy it was. You don't have to write a single line of code like you may have to do earlier to basically get this labels that you would ultimately feed into this algorithm. Now this platform allows you to do this in a very interactive way. Once you have done this, you can now click on the train algorithm directly after labeling. So you can just also see a message appears after saving the complex spike labels. Click this button to use Google Colab's resource for training the network. So now you can just click on this train algorithm button. What this will do is basically it will open uh, your web browser. Uh, the settings of this web browser should be that if you're obviously I'm using a MacBook, so my default settings would be Safari in this case, but the problem is that it does not work with Safari. So please adjust your default browser settings and have them uh, adjusted to Google Chrome, which would work in this case. So what you see here is that it will open a page to train the algorithm in the browser, in your Google Chrome browser. Since you are using the Google Colab, and it's better, it uses the resources of Google, and that's why we are doing this. Now, obviously, you may not feel very comfortable sharing the contents of your Google Drive in case you are having any, and for that, I would suggest that you can create a new account for Google. This is one step, uh, basically, where, yeah, we have to make a little compromise, And in that case, I basically created a new account for this where I'm sure that there is no other information apart from just my complex spike data, uh, which is also without any behavior. So obviously, uh, Google cannot make any sense of that, hopefully. But okay, so what you see here is that there are these 6 simple steps that you would want to run, what you see here. So let's just maximize this a little. And what you do is you press step 1, you let it run. Now you see that the section is running here. This may take a little bit time and will would ask you to provide access to your Google Drive. And basically you say connect to Google Drive. You basically just do this, allow, and there you go. This would take a few seconds, I guess, until it mounts the drive, and there you go. So the drive is now mounted. Now let's install the toolbox on your Google Drive, and by pressing following the second step. So this will take for sure some time. So while this is happening, let me just quickly go back to the main software here, EPICS platform. And what I probably forgot to mention was that you can also, in this case, uh, remove the files that you don't really want. So you can add and remove files as you wish. And I think just to keep it clean, and it's important that you are aware of it. All right, so let's go back again and see how's the progress here. Okay, so it shows you some messages, and like I said, this is going to take some time. Okay, so the step 2 is now finished. It seems like it took some time, and now that you can see a couple of messages happen, and it says it's successfully installed all these toolboxes that were necessary to train the algorithm. So let's move on with next step, which is step 3. So we would now click here, and it would ask us to upload the training data that we just created using EPICS. So you can just say choose files, and you can go to your folder wherever this was stored. So training set is here. Let me just remember where it was. I think I copied it in the folder, and I need to find it where it is now. Let's go back. All right. There you go. And training data. And I basically just upload this. This should not take that long. So while this is happening, let me just quickly explain you step 4. These are basically some technical details, let's say, that in case, so these are some values that you can adjust, but we recommend that if you have your sampling rate somewhere near 25 kilohertz, perhaps do not change these values. These are some default values. You can keep them the way it is and go forward and just see how your network performs. And if you're still not satisfied with your network's performance, then you can adjust these parameters by sliding these numbers here and adjusting them to your taste or whatever calculations that you do. So yeah, just keep it like that. And for now, and yeah, and if you need any further information on this, you can always go back to our original paper that we published. Over there, we give you a description of what these things are and how you may want to change them in case your data is a little bit different than ours, which is basically going to be just a sampling rate and nothing much. Anyways, so let's see what's going on here. All right, so now the data is uploaded. You can see here it's 100% done. And you can now proceed with the next step. I already have run the section before now, and this is already done. You can proceed with the next step, which is training your network. I also did that already. It took me some time, maybe less than a minute or something, or perhaps a bit more. And then it's once the training your network part is done, you can see that it says you can go for the next step, which is basically download your weights. So you click here, and then you can just simply click here to run this thing, to execute the cell. And now your weights have been downloaded as my weights. I can look where it is. Uh, I can copy these weights to my uh, folder wherever I want to store my data. And then basically you can close this window and go back to your EPICS. All right, so now I've shown you how you can label your data. You can upload your files by adjusting parameters that will show you the list of Purkinje cells that you saw before, and you can select each of these Purkinje cells and label your data by selecting or deselecting the complex spikes uh, in parallel with your LFP recordings. Then you would be able to save these individual file labels separately, or you can save all the labels from all cells and create your training data set by pressing this button. This is something that will allow you to train the algorithm. So you will click on this training algorithm button, which will take you to the Google Colab. Remember again, Google Chrome as your browser settings and not Safari. There you will have 6 steps, and if you follow those 6 steps, you will be able to download weights, uh, which will allow you to detect complex spikes. So let's now get to the next step, which is the detect complex spikes part. So we click on this tab, and what you see again is this info icon. Let's see what it says. Oh, it gives you a lot of information on what and how your data should be stored, the format, and all other information that you may need. So let's just put it away for a while. Now what you see is there are two options what you can go forward with. The first option, what you see on the left here, is a single file mode, where basically you can just upload as an individual Purkinje cell. Then you will be asked to upload your weights, basically what you got from training the network, and then you can detect the complex spikes. You can, so if you have many Purkinje cells and you were not sure about those advanced settings, you can perhaps just test one Purkinje cell. Uh, Click here. It will take you to the folder where you have saved your data. You can upload this here and then upload your download the weights that you have downloaded. So again, go back here, weights, and let's say my weight, and then you can press detect complex spikes, and it should basically just detect all the complex spikes in this particular data set. What you can also do is you can select the entire folder, all the cells. So once you're sure, once you're done with this, you can detect complex spikes and directly go to post-processing, and then you can see and evaluate how good the performance of the algorithm was, and you can from their point decide whether or not you want to stay with the settings, and if you're not satisfied, you can go back and adjust those advanced settings that we saw during the training the algorithm part. But if you are satisfied, then you can simply select the folder where the data is stored. So we go here and I select the training set, all these cells, press open. So all the cells have been selected now. I can also select the folder in which I want to save my output data. And what I can do is I can again click here. I can perhaps go to data and label it as output. I can just, well, this has already been done from my previous work, so I can just create another folder here. Let's just call it output 3 maybe, and create this one. Select this folder as my uh, output folder. Now I can download my weights again. Go here, data, weights, my weights. You can select the name of the output file. Uh, I can call it CS output maybe, and let's just go forward. And this is just some other file that will be generated by default along with this output file that will contain your uh, complex spike labels, your embedded IDs from the UMAP, and your start and end times of the complex spikes, which will allow you to calculate the duration of the complex spike as well. So let's press detect complex spikes, and it tells you that 5 out of 5 files will be inspected and all of them match, so everything is fine. Just go proceed. And this will take now some time until it detects your complex spikes in all the 5 Purkinje cell files that you have selected. So let's see how long this takes. And there you go. So the window disappears, which means that your complex spikes have been selected or detected. You can directly go to post-processing now by clicking this button. So once you've pressed this button, uh, what you see here are 4 windows, which will plot your output and the results that you get after detecting the complex spikes. Again, if you go here, you see there's a pop-up window with information, and you can also click again on set parameters. There's one more thing which is added here now is the simple spike train. So if you're recording from Purkinje cells, it's quite likely that you will also record simple spikes, and these spikes can be used to actually uh, detect how well your complex spikes have been detected based on a pause that is triggered by the complex spike. You will just see it in a second. So please save the name of that variable here, and it should match in as it is mentioned on your mat file. So in this case, in our case, all these names are matching. The sampling rate seems to be correct. So we press OK, and we load a Purkinje cell recording. So we just go here and we select it from my training set. So let's just say I select the second cell and I press open, and then I press the output, which should also be matching my output here, which is, let's just go back to my data. Output 3, it was a second cell. So let's just go and click this here, and I think this should basically plot the data, and there you go. So what you see here is um, very nice. So all complex spikes that are detected are shown here. First of all, there were 3 clusters that were detected. So there's this one green dot here and one orange dot or yellowish, and the rest are blue dots. So these are all the complex spikes that were detected in your data set in this case. And the average action potential trace of these 3 complex spikes are seen here. And you can press on select complex spike clusters. It shows you basically all these 3 clusters as indicated by colors here. So here is the action potential trace of the complex spike. This is the LFP trace. The faded lines are individual spikes, and the bold lines are the averaged waveforms to basically help you and see these things more clearly. Then what you see here is the complex spike triggered pause, complex spike triggered pause in simple spikes, and then you see that when the complex spike happens at 0, there are no simple spikes firing for up to 15 or 20 milliseconds in other cases. And this is the feature space as well. Now, if you think that, well, these complex spikes seem to be the same complex spikes as they all trigger the same pause and seem to fit, you can give them the same clusters. So in this case, they all look quite similar to me, but yeah, the amplitudes have changed. It might be that they are well, just over time they just became smaller or something, or perhaps maybe they are really different. So this is where you can decide whether or not these complex spikes are belonging to the same cell or not. I think they do belong to the same cell in this case with some minor differences. So I would just give them all the same color as blue. So now you basically have created just one big cluster of complex spikes, and you will not exclude any complex spike in this case. Or if you were unhappy with this complex spike, you could have just go back and you can change the color of these clusters, and you have now simply disentangled these clusters that were detected by the algorithm. So look back again, we keep it all the same. So now we will have 45 complex spikes that were detected, and we press update. And now, as you can see, all of them are now blue, which is basically just one cluster. And now you can save the selected cluster data in a destination folder of your choice. So let's just click here, and you can now select wherever you want to select your data. You can go back to data and create final output or whatever you want and save this file, which will now contain the updated labels of your complex spikes that you have simply verified. Another thing that you can see here is the setting for plots. I mean, you can adjust how you want your plots to look like. So you can play around with these settings. You can see how many milliseconds before you want to view and how many after. You can adjust that. In this case, it's 5 milliseconds before, and so that's what you see here. You can make it, I don't know, 10 and press OK, and you will see that you can say plot data, and you see that it's now 10 seconds before the complex spike. You can also change other types, like you can change the marker size to 10 just for playing around, let's say. You can press OK and then again plot data, and they become much larger. You can again do the same and uh, change the marker size for these ones as well here. And you can press OK and then again plot data, and now suddenly your complex spike, your simple spike are also much larger. So obviously we have these settings available here. You can play around and see how you would want to view your data. You can also go back again. You can load a different Purkinje cell now, and again go to your training set and choose the last one, let's say here. Then you can say again load output, go back to your output folder, the output 3, one more, and then you select this cell. I'm just making sure that the file matches. Yes, it does. And now you can plot data, and it shows you again all the clusters and all different complex spikes that you have detected. And you can choose the clusters as they were, and you can proceed with the with your selection, so on. Great. So that's all about our EPICS. As you can see, you can again label data, train algorithm, detect your complex spike, either one cell or all cells at the same time, do post-processing, and you can do all of this in one platform. Only during the training algorithm, you move a little bit away from this platform to Google Colab, which is a necessary thing to do right now, since we do not have a GPU in our computer, and not everybody will have it all the time. In some cases, you can have it, so that's good. But if not, then anyone can actually just use this software, and it's very interactive. It's um, easy to use. There's not any coding that you need to do here. It's all click and point and just move ahead and back. You can label your data on one day, you can come back the next day and then just upload your data and then detect the complex spikes on the next day and do post-processing on the other day. So all these three tabs you can run independently. You don't have to do all of this on one day in one go. So which basically simulates our real conditions, because many times you don't have that much time to sit on one day and label 100 cells. So you can obviously do this on separate days and then at your convenience. Find time to perform each step on separate days. All right, so I hope you enjoyed this tutorial, and I really hope that you will benefit from this from our platform EPICS, and collect some really good complex spikes. And we wish you all the best for your analysis and for your research. And we hope that you will be able to record some beautiful Purkinje cells and find some beautiful complex spikes and help push the field forward. Thanks, everyone, and have a great time. Bye.